So we as a company have built up a program around it. I will talk more detail towards the end. It's called Generative AI for Professionals. So that's just one slide about it. Now let's talk about this opportunity of $15.7 trillion economical shift. For is projected by 2030. So no matter who you are, which background you come for, we all are impacted with this change, which came to us in terms of ChatGPT. Normal people understood it as in the form of ChatGPT. But nearest target is $4.4 trillion, and average Americans are impacted about $14,000 around in whatever you do. Let's get started. Please keep dropping your questions. I'll collect it as I keep going. So as I said, this is a transformation product, transition and transformation, which is focused on technical professional leaders, entrepreneurs, and decision makers, or you can say super users of this technology. So let's talk what is new right now. We've been doing AI for a long time, and data science was started like 6 years job in 2015. There were a couple of articles. So what is GenAI? GenAI is a part of AI. So there's artificial intelligence and there's machine learning. Let's see now so there are 3 sections of AI: machine learning, and deep learning, and we'll see how they differ. AI is a discipline, machine learning is a subset of that discipline. Machine learning can be classified in a 2-way, where it learns from many ways. One of the simplest way to explain is this one, it is showed here, is supervised and unsupervised, where you have a labeled data, which we call, that means you know a desired outcome of that. The desired outcome is in the data, and you train the machine learning on it. Unlabeled data is you don't have a desired outcome, but your output will be, I'll show you here a little bit, a probability or a label or something like that. So supervised, unsupervised, where we have a targeted model, predictive, expected train, and some error reduction. This is the process. Unsupervised is when you have an input and the model is trained on, and it generates an example out of it, which can be a clustering problem. If you are non-technical, don't worry about it. This is something technical definitions. So now going to the deep learning side, which is, we said, where these GAN models or generative AI comes into picture. So now this is the full scope of how this technology was developed. So AI, machine learning, and deep learning is the core. So let's look at deep learning. Deep learning can be considered as like your brain neurons, which has multiple layers, and it does some weight management, some biases, some symbiotic function activations, and your knowledge feed it to the one neuron network, get transfer activated to another, and slowly an output is produced. I'm trying to simplify as simple as possible rather than using some jargon, technical or mathematical terms for someone who is a beginner. So this is how your deep learning look like. Now, this is where our webinar is around. What is generative AI? So generative AI is a subset of deep learning. Now, what does it mean? It has 2 kinds of neural networks, discriminator and generator. So discriminative is a classifier which says true or not true, or it can classify whatever you want in a binary output, yes or no kind of. Trained typically on a data set which is labeled, which it knows the outcome is a human or not human kind of a data, and find the relationship in the features between what it is fed on. Now, what is generative? This is the key, right? Generative is a new data which is similar to a data which it was trained on, and understand the distribution, how it likes to give an example and predict the next word or image or voice sequence, basically. So the generative, this is where generative AI comes in. So discriminative, we are building up to the GAN model. Discriminative classifies if it is a dog or a cat, which or human or non-human kind of a deal, or it's true or false. Generative models generates an image. It knows it's a pre-trained model, it's a neuron which will take an example and make a data out of it. So that's what it is. Now let's look at our traditional machine learning models, and let's look at generative models, how they work. When you put a label input data, it finds the relationship between the labels and output is a desired label. In generative, you put an unstructured content, like the whole internet data or something, learns the pattern between unstructured content, and then produces a new content out of it. So these are the outcomes. In non-generative, your outcome is when you put up an input. In machine learning system, can be a number, can be a class, can be a probability. In generative AI, your outcome is a natural language, which is text, image, or audio. So let's look at here. This is more of a technical thing, a little bit. So what does, when you have GenAI supervised, unsupervised, and unsupervised learning, what kind of contents you put in? So training code, labeled data, and unlabeled data. The content can be a text generator, code generator, or an image generator, which you see BERT, GPT, Midjourney, a couple of the tools which are very popular in the generative AI world. So now let's recap what is generative AI. Is a type of artificial intelligence that create a new content based on what it learned from an existing content. The process of learning existing content is called training, and result is created as a statistical model. Given a prompt, which will understand what's a prompt, generative AI use statistical model to predict what is the response might be and generate a new content. So when you prompt, there's a reinforcement learning algorithms which picks it up, scores it, rewards it, understands the condition, and retrain, keeps the training, and then gives you content out of it. I'm seeing three questions. I'll get to it. Make sure nothing urgent. Anil, I'll get back to you, show you an example of supervised and unsupervised learning. This is more focused on the Gen AI part, so I'm trying to build up to that. But yeah, in Q&A, we can talk about it. Thank you for your question. So now generative models and generative image. So you might have used some kind of, if you are on this webinar, ChatGPT, BERT, T5, one of those popular ones, Midjourney. There are millions of them now, so even I don't remember name. So with a language input, you get text output. With an image, you get an image output. So text input can have few outcomes. I will speed this up. Text input can be like, I don't use Grammarly anymore. Sorry about that. You can get translation, summarization, Q&A out of it. Image has videos and image. Now there are models which are able to take your text and make 3D image. That's awesome. Audio and speech and decision game players. I haven't used anything in the game world, so I'm not aware about it. But that's pretty much it. Synthetic and semantic data, you hear about it, but you can literally record your voice and train AI to read for you and produce your own content with your own voice. There are a lot of tools available. There was a very popular incident on the news. Someone took Biden voice and made some sentences. I did not hear about it, and there was a big robocall on it to whoever they wanted to send it. That was part of a generative AI use case. Let's go further. So let's look at how this ecosystem is distributed. Code generation, text generation, and these are the use case: sales email, support, writing, notes, code generation, documentation, image generation, advertisement, you can design your advertisements, voice synthesis. As I said, you can mimic your own voice, or you can take someone's voice on the YouTube and train it and ask what you want to speak. So that's so funny. Video editing, 3D modeling is very powerful. We recently got contacted by someone who wants to build a 3D model for interior design. So that was awesome. And the gaming side, I'm a little bit blindsided. I haven't explored at all. Now, what goes behind the scene? I'm going more deeper. So what are these GAN and how this magic happen? These are called Generative Adversary Network. There was a paper called All You Need Is Attention. I will not go more detail on the scientific side, but if you want to pick something here, that's called generator and discriminator. That's the keyword here. They evolve upon time. So this is what happens behind the scene in large language model. There's a generator, generates a new instance of data, and the discriminator evaluates the authenticity of the generated data. And we'll talk, but these are the two major players you can keep in your mind. So steps for GAN, the first level, a generator. Consider a random noise or image or voice or text, and the discriminator will try to understand if this is real or fake. That's all it does, but it's trained on. These are two neural networks. Generator generates a new image, and discriminator says, is it true or not? If it is not true, it takes the loss function, whatever the errors are, and feedback to generator. Generator fixes itself and produces a new data, and they keep competing until generator beats the discriminator and new content is created. In very, very simplified way. So look at this image. The generator, which is the first neural network in this game, generated something like this zigzag pattern. Discriminator say, no, you're saying it's a cat, it's not a cat. So gave him some loss function. Generator came up with many attempts later, a sketchy image of a cat. And then finally, discriminator said, no, it's not. Look at the first one, the second one. Then finally, generator was able to create a cat image. Discriminator said, oh, maybe it's 90% or 70% true. And a new image is created. So this is what happens behind this large language models. These are tons of them. This is a simple list of which are most popular one. I will not go through all this thing, but this is what is behind the scene. The model is the hand. Please drop your question. I'll get to it. I have to run this faster so that we can get to the Q&A. Now, one more concept before I go further is what happens when you prompt. And if you are a technical person who wants to know more detail, please hold on till last 10-15 minutes. We'll go more deeper. I'm building up to that. But just giving you some introductory concepts in the beginning. So when you prompt, what happens? That's the thing, right? If you're using ChatGPT, we talk about GAN, generator and discriminator are happening. On top of that, there's something called reinforcement layer added on it. So it learns from what you send and what it responds, and reward and penalty system is deployed. So this is how it works behind the scene. That's from the technology point of view. There's 3 things here: agent, environment, state, reward, and action. This is how reinforcement learning works. I will keep it very simple. So when you type something and you correct it, you type something, generator understand, it gives to the ChatGPT. It understands the state. It rewards if there's a reward mechanism. It comes true. If it does not come through, you said, oh, this is not right. There's a learning process. It holds it and reiterates the whole thing. So that is what reinforcement learning is. So for example, the reward is a fish. Here, the cat is sitting. It walks to get the fish. this process continues, and at the end of the day is good. The policy is updated when the true case happens. When the false case happens, the punishment, again, the policy is updated. I'm keeping it very, very high level to make sense for the super users. Now let's look at some GAN applications. So one of the things is peer image to image translation. So you can take a raw image and color it, or translate a blue and white image to a full-blown building, color it. That's one kind of application. Unpair the images. So you can see horse, zebra has been converted to horse. Horse has been converted to zebra. Those kind of applications are coming out. From the entrepreneur's point of view, the use cases are like this. Super resolution, I don't think nowadays we have real images of ours. Most of us use somehow to enhance, including iPhone has that. So you can enhance text to image generation, which is BERT. So you type in something and the image is generated. You might have seen how you look like when you are 60 plus. Those apps are there. That's another model. So keep going further. Data augmentation, where synthesizing a new image of specific class. So as it was aging, now you can look at the same image by changing certain things. Angle, length, width, height, just in simplified ways I'm telling you. So data augmentation is another part. Fill in, if you can see there's something missing, you can fill in. These are the applications. This is very impressive. We work in the fashion and makeup industry, where we are using synthetic and semantic data generation, but this is posture, and you don't need to be having a model to do different postures. Your AI can figure out how it looks on different positions. So this is another model. Restoring the old images is also part of this revolution. The next topic is GPT. GPT is Generative Pre-trained Transformer. That's the name. It's a pre-trained model. So I'm not going to do, but this is what happens inside GPT. You have an input embedding. Embedding is a bunch of words in a paragraph. Then it gets into attention mechanism. From there, it has a feed-forward loop. So this is a whole architecture behind ChatGPT. So as I say, generative pre-trained models, and it evolved from time to time. There's a lot of misconception that there are GPTs, you can openly consume it or create your own. They are trained on large features, what we call it. So LLM versus GPT. These are large language pre-trained models, and GPT is, you have a fine-tuning way where you can dialogue creation and all those things happens here. Prompt engineering. This is one of the things which is very let me see that 4 or 5 questions. Is discriminator classifier? Yes, it is a classifier. Adam, how would you prove that the knowledge is enough to put the resume that are indeed proficiency? And I will tell you, Adam, on that topic. That's a good question. What feeds the data as a discriminator? That's a good question. Just hold on, guys. I'm almost done on this one. These are very, very interesting topics. We'll talk about it. Thank you. So prompt engineering, a lot of us are doing prompting all day for anything to everything. So prompt engineering is a practice of developing optimized prompt, efficiently use the language as model, and prompt design, which is very important, involve instructional and content passing to the language model to achieve certain tasks. There is something called prompt template, which is not mentioned here, which you do as a designer of a large language model, an AI engineer. So you can literally the way ChatGPT is asking you to take an input and the response will be only 1,500 words to 800 to 200, whatever the limit they say. Those are called tokens. You can literally build your own bot, and have more than 1,500 words to be responsive. You can filter, so that's called prompt design, which is not mentioned. But from the super user point of view, that's where it is right now. So there are three kind of prompting: generic language, which predicts the next word; instructional tune. If you use ChatGPT 4, they have this model now. They call it coach model, and then dialogue, which is predict the next response at the highest level. This is from the super user point of view. But what happens behind the scene is when you put sequence of words, a sentence has a correlationship between the words, which is tokenizer. When you write a few words, they get converted into tokens, which are numbers. And so you write sentence A, sentence B, sentence C. All these sentences are converted into tokens, which are numbers. And there's something called word embedding, which take these sentences. First thing is correlationship between those words, and then correlationship between those sentences. So it extracts in one simple way. You can find a meaning, but it's not a meaning. It's just say correlationship in terms of number. So in a simplified way, if you want to understand how it works behind the scene, if you know the concept of cosine and tangent. Cosine is similarities and tangent is similarity and how far they are. So for example, in a very simple way, you have an iPhone and you have an Android phone. They are not similar, but the functionality is same. They make calls, you can check email. So tangentially, they are close. They have the same function. In similarity, they are apart. They look different. Their manufacturing is different. So this is when you connect these two things in a very simplified way, is called word embedding. So when you put up a sentence and you put a few words, the correlationship between words and the correlationship between those sentences, that's called word embedding. So when you put inside the ChatGPT, that's the thing happens behind the scene. I spoke that too fast, so sorry about that. We will cover it in Q&A. So this is what it's saying here. These are some words and some likely words and whatever is happening here. And what happens is in the prompting stage, you get summarize, you can write, and you can extract those keywords from the prompting point of view. The third one is the dialogue, where you can say yes and no. So from a super user perspective, you can use the prompting in three ways. One is dialogue way, one is parent and teacher way, like instructional way, and one is natural language. So when you write a prompt, you can literally think like, are you a teacher or an instructor? Or you can think like, I'm just a casual chatter. Or you can make it in a dialogue way and give a prompt in a sequence way, questions and what you expect them to answer you with the limited length. Let's say you want prompt number 1, A section to be answered in 100 words, B section to be answered in 50 words. And do you want it logical? Do you want it technical? Do you want a formula? Those kind of things you can predefine in your prompt and you will get a very suitable answer. A lot of questions I get it like, how do I be efficient in prompt? If you understand behind the hood, behind the scene, what it does, then it's easy to prompt and beat the GAN model, basically. So this is what a good prompt look like. Now, good prompt. Format your prompt reply and make them more readable. So, is grammar error important? No. It understands, smart enough to understand your spelling, your white spaces. There's technology there's algorithms or some NLP to reduce that. So you can have a normal conversational text, make it a to-do list format kind of a thing. If you give it that way, it will come. Efficient follow-up. So not only you do the first level of prompt, you can also fine tune the prompt and keep going very specific. Most importantly, like is saying, prioritize the task like a professional. You have to give very clear instruction and what do you expect in response. And then share your thread, customize your chat experiences. These are some tips I've picked up from a full-blown book which was written on how to do a prompt, which I felt was pro tips, they called it, so I thought I should share with you. Usually when I do prompt for language, I do write it simple, keep it motivational, and limited words. Otherwise, it picks the way. You can even say, I'm a Californian, lives in Orange County, and write it in a Californian slang, and it will do it for you. So those things are all great. Next thing is, now we understood what's a prompt, what's a GAN, how do you get inside it, what's a prompt, now the next thing is how to fine tune this large language models. So before we do that, we'll jump into what it is. So major applications, as you say, is healthcare and other factor. I'll go forward. This is me. My name is Arshad Khan. I'm the founder and Chief AI Officer in DevMasters, which is the group which is hosting this. And my background is I'm electrical and computer science engineer. I have been doing robotics and AI since my college days. And then later on, I went to Cecil Labs to upgrade myself in deep learning and all those latest technology about 7 years ago. And then I went to MIT Sloan Business School to learn some entrepreneurs skills. Couple of background about us, what we do. We have been rated quite high in a couple of the big rating groups. We have been in business since 2015. So that's our background. Our top clients have been US Navy, General Electric, some of this which you are seeing here. Okay.
St. Philip's, yeah, that's my email for my St. Philip's College. I'm going to school for cybersecurity.
Awesome. Cybersecurity has big use cases too.
Yeah, and all different kind of techniques. So, that's one of the questions I had, and I just want to thank you for sharing some of your knowledge.
Rebecca G, I'm interested in a couple of your courses. Can you please suggest a name to your staff? Thank you, Rebecca. We got your name. I will have this. Sean, I took care. Adam. Awesome. I'm still available. Anyone else? This excites me. It makes it worth to do it, right?
Yeah, I'd like to ask a quick question about hallucinating. It's kind of too broad of why it does that, but I guess if it's too many vague prompts, the computer will hallucinate. Or what has been your experience of the most repeatable causes of hallucinating?
I'm hallucinating myself to start with in a simple way.
We could all be just in the matrix for all we know.
Yeah, I from finance to fashion to it's so exciting. So but I haven't. Maybe my mind is different and the knowledge level is different. So my prompting does not hallucinate, and fine tuning does not, because I'm very specific in input what I give, and the desired output I wanted. But
that's actually a pretty good answer of when somebody becomes a very good prompt engineer. They'll see the fine tune of, hey, I didn't put it enough of a boundaries for the computer to stay in. Thanks.
No problem. Yeah. So behind the hood, if you understand how it works, but I haven't gone that far yet. When I can crack it, I haven't gone there. Yeah, Preeti.
I have a question around just data privacy, GDPR, and all of those type of processes. How well are AI solutions now able to meet those requirements, and what are some of those this is probably a huge topic, but what are those, if you could summarize, what are those challenges right now?
Yeah.
And is it as big of a challenge as it seems like it is?
So it is challenging very much, but there is. I did a talk on Ideas Conference on this topic, so I have some insight, but not to a level of an expert. So from doers' point of view, right, we build algorithms and we want to be accountable for what we are doing. There's a concept called XAI, not X platform, which IBM has it and I adopted it. So every significant process in the AI build, we kind of create an index or a neural network layer where we document the feed coming in and feed going out. That creates an accountability of how AI is progressing from the machine learning or deep learning point of view. That's one way to audit. Now, from what we had senators grilling Mark Zuckerberg and other people. I don't know the compliance part of it, how they are doing it. And MIT also and Facebook came up with ethical first draft of it. That's all I know.
Thank you. Thank you for sharing that. I'll do my research on my end as well. Thank you.
Thank you, guys. It's always exciting to meet everyone, and I get very encouraged even doing this on weekend. I really appreciate everyone participating, and hope to see you in the next ones. And I'll try to keep it as informative and as valuable possible for everyone. Thanks again. Have a good
Thank you, Arshad. Really appreciate your time and shedding the light on these technologies.
Thank you. Thank you, everyone. Thank you, Pritish. Thank you, Sean. Thank you, enormous user, Keith, Rebecca, Adam, and sorry if I missed some names. All right, guys, have a good weekend.